Hi mathematicians. In this video, I'm going to review the study guide for your upcoming test. And question number 1 asks us, which statements must be true? So which statements must be correct about the data represented in the box plots? And option A says that Mr. Wolf's class typically earns higher scores. So Mr. Wolf typically gets higher scores. So let's look at our data. This shows where most of Mr. Wolf's class is. So most of Mr. Wolf's class got 85 or higher, which I've represented here. Most of Mr. Fox's class is represented here. So most of Mr. Fox's class got a 70 or higher. So Mr. Wolf's class did have higher scores than Mr. Fox's class. So A is a correct answer. However, the question says statements, more than one. So that means that there could be more than one right answer. So we need to check the other options as well. Option B, asks us to look at the middle half of the data for each class. So the middle half is right here inside of the box because that is the middle. And option B says that Mr. Wolf's class has more variability. Remember that variability means spread. So if we're looking at the two classes, Mr. Fox's class is the one that has more spread. But the question says Mr. Wolf's class has more spread. So this answer is wrong because you can tell that Mr. Fox is more spread out. So Mr. Fox has more variability, not Mr. Wolf's class. Option C says the median for Mr. Wolf's class is less. Well, the median, remember, is right here for Mr. Wolf's class, and the median for Mr. Wolf's class is 90. The median for Mr. Fox's class is here, and the median is 80. So this says the median for Mr. Wolf's class is less. Well, for Mr. Wolf's class, the median is higher because 90 is higher than 80. So that means that this is not correct. So we're going to say no for option C. Finally, option D talks about the total number of points earned. On a box plot, there are individual student scores that are represented by the box plot, but the point of a box plot is just to provide a summary of all of the numbers in one graph, and a box plot does not show the individual number of points. So you cannot figure that out from looking at a box plot. Therefore, answer D is also a no. So option A is the only correct answer. Question number 2 asks you to calculate a variety of calculations based on the Summer Olympic gold medal finalists. And remember that you have your calculator cheat sheet that reminds you how to find most of this data. So remember, the calculator will give you the mean, the standard deviation, your minimum, your Q1, your median, your upper quartile, and your maximum. So if you don't remember how to use your calculator to do that, please review the video that I made that reminds you how to do that. So here I've used my graphing calculator, to enter the data and to obtain some calculations. So the first one I have, remember, this is the mean, and it doesn't really matter how you round for this. I'm not going to be too hard on you for that. 21.9 will work for this one, or if you want to do 21.89, that's fine. But as long as it's somewhere, I'm not going to be too picky. Then remember that the median is given to you here. So the median is 11. The graphing calculator also gives you your Q1, which I'm going to put right here. It also gives you your Q3, which goes here, and it gives you your minimum of 5, and it gives you your maximum of 81. If you don't remember how to find the rest of the data, remember that you have a cheat sheet here that reminds you how to find the rest of the data points that the calculator does not give us. So make sure that you have this handout the day of the test. Oops, I forgot one thing. Sorry, guys. I forgot to tell you that the calculator also gives you the standard deviation, which is right here. And again, it doesn't really matter how you round. 22.5 is good enough for me. Sorry, forgot to tell you that one. Now, using our stats cheat sheet, I'll remind you how to find the other measures on here. And remember that the mode is the one that appears the most often. So not the maximum. We're not looking for the highest number. We're looking for the one that occurs most often. And in this case, we have two numbers that repeat. We have 18 that occurs more than the others, and we have 10 that occurs more than the others. So you have two modes, 10 and 18. Also recall that the IQR is your Q3 minus your Q1. So that means we need to take 26.5 and subtract 9.5. And that is going to get us 17. And the range is your minimum minus your maximum. So we need to say 81 minus 5, which gives us 76. To answer problem 3, you'll want this handout, this notes page that we did in class, but I'll talk about it in just a second. And so number 3 is asking, first, what measure of center is the most appropriate for this distribution? And if I look at the box plot that I have here, and I make a line through the center of it, you can see that on both sides, it's symmetric. It looks about the same on both sides. This side looks about equal to this side. So when they are symmetric, remember which data set you use. I'm going to return here to my cheat sheet. So see where it says if it's symmetric, you use the mean as the best measure of center. So since this data set is pretty symmetric, that means that the best measure of center is going to be the mean. And where it says explain your reasoning, you don't need to write me a whole bunch of information. You can just tell me that your reason is that this is a symmetric data set. Part B is a little bit confusing, and I'm sorry that we set this up to be confusing. I realized this probably wasn't the right way to go, because it says add the appropriate measure of center to this box plot. Now, what you might want to do, because it's a box plot, and you know that a box plot has the median, you may want to put the median in there. However, that would not be correct, because the appropriate measure of center in this case is the mean. So I used my calculator to estimate that the mean is about 4.3. It's pretty close if I round. So don't put a line at 4.3. Just put a data point right here and label it as 4.3. Because a box plot, if you put a line in the box plot, the line in the box plot would be the median, which is not the most appropriate measure of center. So just label the mean. Finally, part C asks you, what is the most appropriate measure for variability in this data? And again, I'm going to go to my cheat sheet. And again, we're still dealing with data that's symmetric. And when it's symmetric, the standard deviation is a good measure of variance. So our response here should be standard deviation. And to explain your reasoning, you can just say the data is symmetric. Question number 4 is asking us to complete the histogram. So this part of the histogram is already done for us, and this part of the histogram is already done for us. So the one we need to do is here. So because there are 30 students, we need to make a bar that goes up to the 30. I'm going to zoom in here. We need another bar that goes up to the 30. Remember that on a histogram, the bars are sitting right next to each other. We also need to add a label. And the label for this one should be 10 to 14. So we need to stick a label to show that 30 students watched between 10 and 14 hours of TV. Then we need to look at our next bar, which is here. So because 10 students watched TV between 15 and 19 hours, this bar needs to go up to the 10. And we need the label of 15 to 19. So that takes care of part A. Part B says to use the shape of the distribution to compare the mean and the median. Are the mean and the median equal? So remember from the previous problem that if the data is symmetric, the mean equals the median. So let's see if this is symmetric. So this part of the box plot is symmetric, but This little part right here is a set of outliers. And those outliers are going to skew the mean, so that the mean is greater than the median. So again, this part right here is symmetric. If it were symmetric, then yes, our mean would equal our median. However, this part right here skews it so that the mean is bigger. So the answer to our question, are the mean and the median equal? We're going to say no. If not, which is greater? The mean is greater. And why? Explain your reasoning. Because the data is skewed. For number 5, it says select all the statements that must be true. So we're going to start with A. And A says Jacobi scores have greater variability. So again, remember variability indicates spread. So if we look at the spread of Jacobis and we compare it to just how spread out, we're not looking for bigger numbers, we're just looking to see how spread out it is. And actually, their variability is the same. They are spread out the same. So greater variability, nope. So option A is not correct. Next, it asks if the standard deviation of Jacobi scores is equal to the standard deviation of Martin scores. And remember that standard deviation measures your variability. So since they're both the same variability, that also means that their standard deviation is equal. So B is one of our correct answers. Next, it's asking us to compare the mean of each of the scores. And both data sets are symmetric, which means that the mean is typically going to be right here in the middle. So Martin's mean is greater because Martin's mean is 6, but Jacobi's mean is 4. So the mean of Jacobi scores is not greater than the mean of Martin scores. So this one is going to be a no. I'm going to skip D for a second and look at option E because it's relevant to what we're doing right now. So for Jacobi, it says Jacobi scores, the mean is equal to the median. So again, when they're symmetric, like these are here, the mean does equal the median. So this is another one that is correct. And for option D, it's saying that Jacobi scored better. So in this case, better means higher. So they're asking, were Jacobi scores basically higher than Martin? So if we look up here at our data set, you can see that Jacobi scores are overall actually lower than Martine's scores because most of Jacoby's scores are over here to the left where lower numbers are. So that means that Jacoby did not score better. So this one is also a no. So the two answers that are correct are B and E. Number 6 asks us to select all the answers that must be true. So let's look at A. A says for company 2, so for company 2, only the median value is shown. So that would mean only one value. Well, here we have lots of values. We don't just have the mean. So this one is not true. Option B asks us if the standard deviation for company 2 is less than the standard deviation for company 1. And standard deviation measures spread. So if we look at the spread of the two dot plots, this one is more spread, which means it has a greater standard deviation. So company 2 is not less than company 1. It's going to be more spread. So option B is a no. Option C asks us to analyze the median values. And it says the median for the two companies is lower with company 2. So remember, the median is the middle. So in company 1, here is the median is going to be about here. For company 2, the median is going to be about here. So this one is lower. So option C is correct. Option D says the median value for company 1 will change only a small amount if somebody has a very high salary of $500,000. Because you can see currently the highest salary is $130,000. So if we added this $500,000, it would be out here somewhere. And this would be considered an outlier because it's much greater than the other numbers in the data set. So what happens? That outlier, remember, is going to skew. That means it's going to throw off. Outliers skew the mean, but not the median. So that means if we added an outlier, the median value would change only a small amount because it does not skew the median as much as the mean. So that means that option D is correct. And that also means if I look at option E, it says the new salary of $500,000 will affect the median values more. Okay, so again, not the median. They do not skew the median. So this is not correct. So E is going to be a no. So the two correct answers for number 6 are C and D. Okay, in this question, it is asking us to compare two histograms, and I'm going to zoom in on this important piece of data. Each data set contains no outlier. So what is the most appropriate measure of center? So it doesn't contain an outlier. So no outlier. Oreo, I'm recording. Stop meowing. No outlier equals no skew. So the best measure of center is going to be the mean. And the most appropriate measure of variability is going to be the standard deviation. Part B asks you to compare using the measure of variability and the measure of center that you were given. So, and it actually gives this information to you. I've got to zoom out here a little bit. So the measure of center is given to you by the mean in each data set. So the mean for the, let me see here. So the mean for the brand cereal is 289, which is higher than the mean for the generic. So the mean for the brand cereal is higher. And again, it's given to me right here because that one is 289, whereas that one is 249. So the mean for the brand cereal is higher. Now let's compare the measure of variability. And the variability is given to you also up here with the standard deviation. So this standard deviation is higher for the generic cereal because this one is 26, whereas that one is only 19. So the standard deviation for the generic cereal is higher. So the mean for the brand is higher, but the standard deviation for the generic cereal is higher. Part C says that an outlier for the brand cereal is added. So remember this important fact about outliers. Outliers skew the mean. So the outlier would most likely change significantly the mean. And the reason for that is, okay, to explain your reasoning, outliers skew the mean more than the median. Because the median is mostly going to be in the middle, whether you add an outlier or not. Sorry, I realize my handwriting is not the best here. So again, for your reason, outliers skew the mean more than the median. And with the same reasoning, the standard deviation, outliers skew the, the standard deviation more than IQR. Remember IQR? If you're looking at a box plot, the IQR is the middle, and the middle is pretty much always going to stay in the middle, so it doesn't really get skewed by outliers either. For question number 8, you're going to want this reference sheet that we did in class, and you're going to want to pay the most attention to this part right here. I'm going to zoom in here. So remember that, see how this one is clustered around the middle? That means that this one is going to have less variation because it's less spread out. And how this example from class is more spread out on either side, which means it has more variation and more spread. So more variation means that your standard deviation is going to be higher. So let's apply it to our problem that we have here. Notice this one is more spread because this one is clustered around the middle. So more spread equals a greater standard deviation. So your answer is histogram A, because histogram A has a standard deviation that is greater because it's more spread.